Kepler's laws. Planetary motion had been observed by astronomers since ancient times. Before Galileo, all observations of the planet's position were made by the naked eyes. By the 16th century, a lot of data were available about planetary positions and motion. Johannes Kepler studied these data. He noticed that the motion of planets follows certain laws. He stated 3 laws describing planetary motion. These are known as Kepler's laws. Do you know? An ellipse is the curve obtained when a cone is cut by an inclined plane. It has 2 focal points. The sum of the distances to the 2 focal points from every point on the curve is constant. F1 and F2 are 2 focal points of the ellipse shown in the figure. If A, B and C are 3 points on the ellipse, then AF1 plus AF2 is equal to BF1 plus BF2 is equal to CF1 plus CF2. Kepler's first law. The orbit of a plane is an ellipse with the sun at one of the foci. The figure shows the elliptical orbit of a planet revolving around the sun. The position of the sun is indicated by S. Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. AB and CD are distances covered by the planet in equal time, that is, after equal intervals of time. The positions of the planet starting from A and C are shown by B and D respectively. The straight lines AS and CS sweep equal area in equal intervals of time, that is, area ASB and CSD are equal. Kepler's third law. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. Thus, if r is the average distance of the planet from the sun and t is its period of revolution, then t square proportional to r cube, that is t square upon r cube constant, is equal to k. Equation 1. Kepler obtained these laws simply from the study of the positions of planets obtained by regular observations. He had no explanation as to why planets obey these laws. We will see below how these helped Newton in the formulation of his theory of gravitation. Use your brain power. If the area ESF in the figure is equal to the area ASB, what will you infer about EF? Answer. According to Kepler's second law, the line joining the planet and the sun sweeps equal areas in equal intervals of time. Hence, the time taken to cover the distance between E and F will be equal to the time taken to cover the distance between A and B. Introduction to scientists. Johannes Kepler, 1571 to 1630, was a German astronomer and mathematician. He started working as a helper to the famous astronomer Tycho Brahe in Prague in 1600. After the sudden death of Brahe in 1601, Kepler was appointed as the royal mathematician in his place. Kepler used the observations of planetary positions made by Brahe to discover the laws of planetary motion. He wrote several books. His work was later used by Newton in postulating his law of gravitation.